Well, in this chapter, we are going to deal with limits, and we have three examples here. In the first example, we have a continuous function. Okay, this is a polynomial, and this is just the power of some polynomial, and taking a power is continuous. Here I see a cubic root, by the way. If this was a square root, we might have some points where this function is undefined, so we should be careful about that. But for a cubic root or other root of some odd power, then we are not even worried about if the function is somewhere undefined or not. I know you guys didn't learn yet what continuous means, but for continuous functions, we have that the value of the function at that point is equal to the limit. And here, if you guys want to also check, you can just prove it with the definition of the limit, of course. And here, if I plug -3 inside, and if I get some nice answer, then I am done. Which is 16. And which rules did we use in between? Here we have power, root, law, limit laws. Actually, maybe I should write one more step. This is the power root law. And here we're using the limit of 5 is 5, so we are using sum and difference law here. When can we use these limit laws? As long as the limit exists, but it exists, so we don't have a problem. But you should always check that, because I sometimes see in the exams that you guys write, I don't know, some expression here, and I mean, limit goes to somewhere. And instead of that, you say, this is true, and you do some cancellations after that, I don't know, and you write something as the answer. Maybe your answer is also right, but in the worst case scenario, what we see is here we have like 0 over 0, which is not allowed because you are using the quotient law here, and in the quotient law, you cannot have 0 or infinities. So when you're using limit laws, just be careful. If you write something like that, probably you will get no points from that part. All right, the next one. So we have a problem here because h goes to 0 and h is in the denominator. So we have to just modify it a little bit, like massage it a little bit so that we can cancel this h. And actually, if I multiply it with its conjugate, I see that 5h is going to be here, and these two will cancel each other. Then I can cancel the h, then we would be done. So the conjugate, that is this. And so what I am doing here, I'm just multiplying with 1, nothing more. These two are canceled. Now we can cancel these two h. But why can we cancel that? This is kind of important. We see that h goes to 0, but under a limit, you are kind of assuming that h is going to 0, but h is never 0. It is just approaching to 0. So as long as h is not 0, we can cancel them. So this cancellation is allowed under the limit, only under the limit as h goes to 0, because this means that h is going to 0, and the important part is h is not 0. Since it is not 0, you can cancel them. Otherwise, we cannot. Then we can plug in 0, right? Here we have 5, here we have 4. Out of square root, it is 2 plus 2, 4, 5 over 4. And yep, the last one. Here we can use the factors. I mean, we can find the factors and cancel the ones with u minus 1, right? Because u goes to 1, this is 0 over 0. We should have two factors in the numerator and denominator of u minus 1, hopefully. And we have here, like, as u equals to 1, as u minus 1 times this. As we talked about in the previous part, These cancel, and we can plug in 1, which gives 4/3. So here it is important that you know which law you are using, and if you are allowed to use that, you should just check that, because if you are not, you will lose points from that part. And it doesn't matter if you get the correct answer or not. It is very important that you guys write everything very clearly, very rigorously, showing each step. We check that if you know what to use and how to use it. If we don't see it, we are not giving any points. If you did it wrong, but you found the right answer, we are not giving any points again. Be careful about it in the exam.